Yes, in this class, I will discuss about another important time event. Latest available occurrence time, which is denoted by TL. In the earlier lectures, I have told about the small TE and capital TE. Small TE is the expected time of a particular activity. Capital TE is the earliest expected time of an event. So capital T represents to an event, small t represents to an activity. Similarly here, this TL represents to an event. It is defined as it is the latest time of an event. An event must occur. Suppose if you take an event, maybe 3 or 4 is an event. It is the latest time. That means some time gap is allowed. So there is a difference between your earlier time and the latest time. So they always, if you take up a project, they will insist upon a latest time also and earliest time also you can calculate. So by that time that project should complete. So they should not take more than that time. That is it is a maximum time limit we can say to keep the project on schedule. So it is also called as, suppose if you calculate the latest available occurrence time TL for the last event, it is also called as scheduled completion time or denoted as TS. So for the last event, in this example, for this last event, whatever TL we are going to get, the pixel is your TS. That is it. Now let us understand how we can compute this TL. In the last lecture, last video I had explained how to calculate this TE. In this video, I will tell how to compute this TL value because both are important in any network. So here this TL is calculated like this. Now we have to move in the backward order. So when for calculating TE, we are taking Ij. In that Ij activity, I is the first event, J is the next event, like that. Here we are going the reverse way. TLI we are going to calculate, which is equal to TLJ minus TE of Ij. This is the formula we have to use for calculating the TL value. So here it is minus. Please note that when you are calculating TE, in the last video I had told, TE of J will be equal to TE of I plus TE of Ij. Here it is plus, whereas here it is minus. So this is the formula we are going to use to find the latest available occurrence time of an event. Ith event is given by TL of jth event, that is the event number 2, minus the activity time. So this is what we are going to use. Now for this example, it's a single path example. Let us see how we can calculate this final value of TL. So all these TL values are written below the circle. So TE values are written above the circle, TL values are written below the circle. Let us see how we can calculate. So we have to move in the backward sense here. Backward sense we have to move. Now, in this case, what happens? We will be knowing the TS value. That means at what time that project has to be completed or scheduled. So let me take this. I will take this as 25 units. Let us take this as 25 units TL value for the last event. I am going to take as 25 units. Now I have to find out TL value for event 3, event 2 and event 1. TL value for 4 is known. That means that project should be completed at the most by 25 days or 25 hours. So normally it is in days. So 25 days. Then at what time? At what time third event should be completed? At the most, and at the most, at what time second event should be completed, and at most, at what time first event should be completed. So here we have to move in the backward sense. So now let us use this formula now. So we know that TL for 4, even 4 is known, which is equal to TS, which I will give it as 25, maybe days. Now let us calculate that TL of 3. So we have to move in this sense. T is calculated in the forward sense, TL is calculated in the backward sense. So if you use this formula, So it is TL of 4 minus TE of 3. That's what. Okay? You have to subtract. Now TL of 4 is 25 minus the time taken for this activity 3-4 is 9.5. So 25 minus 9.5, which you can take it as 15.5. So that means at the most event 3 should be completed within 15.5 days. Next we will calculate TL2 for the second event. It is nothing but TL3 minus TE of 2-3. This activity we have. This activity 7.5 days. Okay. So that means here TL3 is 15.5 minus 7.5 for the activity 2-3. So if you subtract, you get 8. So at the most, the second event should be completed within 8 days. Next, TL1. TL1 is calculated as TL2 minus TE for 1-2 for the event 1. Now that means it is 8 minus 6. That is 2. So what is the meaning of this? The first event should be completed by within 2 days. So actually we are expected time is 0. So suppose if there is some delay is there, up to 2 days it is allowed. That's all. That is the meaning of that. And if you start like that, then what happens? This TL if I write, so this TL is equal to 2 for the first event, TL is equal to 8 for the second event, TL is equal to 15.5 for the third event, and TL for the fourth event is nothing but your scheduled completion time DS, which is 25. So in this case, we will be knowing the last value. From the last value, we are moving backwards to compute the TL value. Now this is for a single path. Suppose if we have multiple paths, then how to calculate? So then in that case, so what we did in the case of capital T, same procedure is followed. Only thing is here we have to move backwards. So here we have to move like this. Let me take the same problem which we did in the last video for computing TE. So in the last video, what I did, the problem values I have written here, the network I have written here, I have shown all the TE values and capital TE values here. Now I want to find out the TL values for all the events. So TL values for all the events. So TL for this, I want to compute. TL for this, I have to compute. TL for this, TL for this, then TL for this, then TL for this. Okay. Now let me take. We have to move in the backward sense. So let me take that this TL value for the last is known 27 only. So this TL is equal to TS. Now using this and using all these T small T values, how to compute TL values for the other events. So like that we have to see. So here one thing is, when you are calculating capital TE, you are taking the maximum of sigma TE values as capital TE value. In this case, we have to take the minimum of TL value, that is the sigma TE value, that is the important thing. So we are going to consider minimum value of TL, minimum value of TL for multiple parts. To calculate TL, we have to take the minimum value. Let us see how we can do that. So this is the given problem. Now the question is, we have to find out the TL values for all the events. Now let us take one by one. I will start from the last one. So last one is known here. For the sixth event, we know the value of TL. Now for the fifth event, using this we have to compute. So for event 5, TL5 is equal to TL6. We have to take TL6, we have to move backwards, minus TE of 5, 6. Okay, whatever is there for 5, 6, this we have to take. So that means 5, 6 is here 5. So therefore it is 27 minus 5, which is 22. So we got the value 22. Now for event 4, let us calculate for event 4. For event 4, if you use the same formula, these two are the events and this is the activity, 4, 6 is the activity. So I have to move like this backwards. It is TL6 minus, this is TL4 is equal to TL6 minus T of 4, 6. So which is once again 27 is TL6. So TL6 is 27 minus T of 4, 6 is 8. So this will be 19. We have to take 19. Next for 3. For 3, see here. So there are 2 arrows connecting to 3. So for event 3, you will be having 2 values of TL. You should be careful here. One value for this activity, another value for this activity. So you should be very careful how many arrows are coming to that event. So here for 5 there is only one event, for 4 also there is only one event, but whereas for 3 there are, for 5 there is only one activity, 4 also there is one more activity, but for 3 there are 2 activities, one is 3, 6 and another is 3, 5. So you have to calculate TL for both the cases. So here for event 3 I can write like this. So TL3 is equal to, suppose if I take this, TL3 is equal to TL6 minus T of 3, 6. So TL6 we know that it is 27 minus T of 3, 6 is 4. So it is 23. Next, by taking this 3, 5, so TL3 can be found out by taking TL5 also. We are going backwards like this. TL5 minus T of 3, 5. T of 3. So TL5 already we have calculated here 22. 22 minus T of 3, 5 is 7. So it is 15. Now we have to take the minimum among these two. That's what I have told you. So this is the minimum. So in event 2, you have 2 values. So out of those 2 values, event 3 you have 2 values of TL. Out of that we have to take the minimum value for further computation. So next, event 3 we got the value of TL. Now let us write, let us go on writing it, whatever is we have got there. For event 5 we got 22. So event 5 TL is equal to 22. For event 4 it is 19. 19. So this is over. This is over. Then for event 3 we have to take minimum, that is 15. So this is 15. So whatever is left now, so we got, this is given, we got this, we got this, we got this. Now left out is 2 and 1, only these two. So once again for this 2, if you want T and 2, so only one arrow is coming to 2. So the successor is 3 here, successor event is 3 here. So we have to take TL of 3 minus T of 2, 3. That means it is 15. TL of 3 is 15. 15 minus 10. So it is 5. Latest time for event 2 is 5 days. Next, coming to 1. So TL of 1 is equal to, there is only one arrow. So it is given by, oh no, so for 2 you have from 4 also. So you should be careful here. TL2 also will be having 2 values. Because there are 2 arrows coming and meeting at 2. So the other one is coming from 4. So it is TL4 minus T of 2, 4. So TL4 is 19 minus T of 2, 4 is 8. So 19 minus 8, it is 11. 11. You got 11. Okay. Among these two, the minimum is 5. This we have to take. So this we have to take for further computation. So whenever you have 2 or more values, we have to take the minimum value here. Whereas when you are finding TE, you have to take the maximum value. Yes, now lastly, so this TE, now we got TL for event 2, we have got 5. Now lastly, we need TL1 for the first event. So TL1, there is only one arrow. It is nothing but TL2 minus TE of 1, 2. So TL2 is 5 minus TE of 1, 2 is also 5. Therefore it is 0. So that means there should not be any delay. So this is 0. We got 0. So this is how we can compute the latest available occurrence time TL for a given network. So the data is the last TL value should be known, which is nothing but your TS, and the small TE value should be given. So you have to proceed in the backward manner using this formula. And whenever 2 arrows, more than one, that is 2 or 3 arrows meeting at an event, you have to calculate so much number of TL values for that particular event, and the minimum value is considered for the further computation. So this is how we can find out TL and TE. So both are important. So these are the TL values. So that means, in other words, what I can say here is, suppose if you consider event 5, the meaning of that is, what is the meaning of that TL and TE? Event 5, you have TE value, you have 22 hours. TL value is also 22, okay? Maybe hours or days. So both are equal here. That means in this case, there is no slack here. There is no slack. So the difference between these two is called as slack, latest minus earliest. So that means in this project there is no question of extension of time. So your difference is 0. Whereas if you take event, I will take event, one more event, I will take event 4. If I take event 4, the value of TE for event 4 is 13 and the value of TL is 19. That means event 4 can be completed at the earliest by 13 days, or it should be completed by 19 days at the latest. So it can be in between those two. So that event 4 can be completed in 15 days or 16 days, like that. So they are fixing the minimum time and maximum time for a particular event. That is the meaning of that. Of course, the starting time is same. TE and TL for the first event is same. For the second also it is same. For the third also it is same. For fifth also you are getting same. But for 4 you are getting different. Okay. And of course for sixth also you are getting same. So only in one event that event can be completed within these two timings, earlier, latest. So this is how we can compute TL value for a given